Okay, we're going to talk about variables as objects. And it's a little strange, but because we haven't really explained what objects are, but I'm going to try and do this anyway. So, we've said in the past that buttons are objects, and all these controls are objects, or examples of objects. So basically the idea of an object is that somebody, first of all, somebody in who made this language, Microsoft Visual Basic, somebody at Microsoft had to decide like which of these to create for us. You know, we might want something else on the screen that isn't one of these objects. You know, who knows what you would want on the screen, but it certainly may not be in this list of objects. But they made these objects for us. They made these controls for us because they thought, oh, these are, you know, people definitely want these, and let's make them, let's write the code for them, and people can use them. So so we have this set of objects, and that's basically the idea of objects. It's the programmer will decide to make an object, and along with making the object, besides just making this image of a button, they want to make give it have certain properties associated with it, and we know all about that, right? When we click on here, we can see all the different properties. It's not very expanded here, but we can see all the different properties here, and they say, okay, well, the button is going to have this property and that property and all these properties, and of course the picture box has a different set of properties, and so each object has its own special set of properties. And in addition to that, each object has different methods associated with it. So like a date time picker, I think we used that once before, that will have a certain set of methods, and the button will have, you know, possibly a different set of methods, right? Because I don't know, we want to do different things with buttons, and we want buttons to be able to do different things than we want something else to be able to do. So each object will have its own set of methods as well. Now there's this other idea, which is that, let's see, do we have an example of it here? I'm not sure we have an example of it here. But yeah, let's see, we might have special kinds of buttons, and we don't actually have, I don't think we have special kinds of buttons, but we might have what's called a button class, and then we might have special kinds of buttons. What could be a special button? Well, we don't really have it, but maybe we would have like a special button that would be a round button, and a special button that would be a square button, and a special button that would be triangular button. That's not great examples, but still. So we could have general buttons and then special types of buttons within those. Okay, and that's typical of object-oriented programming. First you define a kind of very general object, or a general class it's called, and then you have sort of specialties of that class, and then you could even have specialties with the specialties, and so on. And we say the specialties inherit the properties of the original thing. So we might have some buttons might have some certain methods. For example, if we go to buttons, they have all these methods, right? We've seen this before. Okay, all these different methods associated with the buttons, right? One of them is the click method, but there's many others. And then if we have special types of buttons, like a triangular button, they will inherit all of these methods. So if you have a triangular button, it will have all of these methods as well. And then you can add additional methods to the triangular buttons. You know, maybe triangular buttons need to do some extra special things. So you will have some additional methods that the general button class doesn't have, that triangular buttons will have. And the same thing with properties. You might have some special properties for the triangular button that the general class of buttons doesn't have. Okay, so this is kind of the idea behind object-oriented programming. Now I'm going to show you just a web page about this, which I never can really find a great simple introduction to objects, but let's look at this one anyway. So let's look at this called WikiHow, How to Understand Object-Oriented Programming. Alright, so let's see if we can go through this quickly. It's quite very short. Understanding object-oriented programming can be difficult. Okay, but that doesn't help us very much. Understanding that there are generally three main parts to object-oriented programming. These are abstraction, inheritance, and encapsulation. So you can look these up and try and read through what they are. In object-oriented programming, programs are designed with the concept of objects, where each object contains its own set of variables. So we're talking about the button. So we design a button. You know, maybe the button doesn't exist and we have to design it. Okay, so we design a button. We have a button class so that we can create buttons whenever we want to. That's called, when you have a class, which is kind of the blueprint for buttons, and then you create an actual button, that's called object instantiation. We create an instance of the button class. It's called object instantiation. Anyway, so anyway, each class has its own set of variables. So buttons have a certain set of properties, right? That's what they mean by variables. Buttons have a certain set of properties, like the color and the size and so on, to store data about that relevant object, to store data about or relevant to that object, right? So we have different properties for buttons. Those are the different variables, and functions to perform actions. So we have functions means methods. So we can we have lots of different methods for the button class. I just showed you all those different methods. For example, the click is one method. Other methods might be maybe an object does a certain kind of calculation, or anyway, it can do lots of different things. And then they say this contrasts what's called structured programming, which is sort of the old kind of programming, which doesn't have objects. Okay. So objects represent various things in a program, like a square. Okay, so they're talking about, suppose you have an object called a square. This is called abstraction. So, in other words, it's not actually a square. It says it represents a square. An object for a square in a math program would have a set of variables, length and width. So if you're just talking about a simple square, maybe the only variables you need are length and width. Maybe you don't need color, especially if you're talking in the sense of a math square. You're not really talking about the putting a square on a page, but just the idea of a square. So just like a square in terms of mathematics, then maybe all you need is the length and the width that can only be accessed by functions inside the object. That means these variables, you can't access them from outside of you can't change the length or the width of a square from outside of that object. That's not exactly clear what that means, but this is called encapsulation. Anyway, these variables are only accessible through the class itself. That's not very clear. This concept reduces the chance of breaking something when programming, as when done properly, only the object itself can directly manipulate its variables, so debugging problems is easier. Then that's not so clear either. The next part of an object, functions, represent things that the object can do or ways that it can interact or ways to interact with it. in the case of the square object, a function called area. So we might want to attach a function to this object called the area so that we can just access that function and get and if we have a particular square, we can just generate the area. We would calculate the area of the square the object represents, using the contents of the length and width variables inside the object. Those variables may already contain the length and the width of the square. In case they did not, the area function might also take user input for the length and width of the square the objects represent, and then calculate the area based on the user input. Okay. Okay, now they sort of explain this in a backwards way, because here they say, in the case a math program was intended to calculate the area of not only squares but other shapes, such as, so suppose you're also going to need to calculate areas of circles and other shapes. They say inheritance would be used. Inheritance is when an object is created based on another object. So actually this is backwards, because first we would create a general object, and then we would create a square and say the square inherits some of the properties of the general object. So now they're going backwards. They're saying, let's talk about the general object. I already talked about the square. So anyway, in terms of what I was saying before about buttons, we'd have a general button, and then triangular buttons would inherit the what do they say? Maybe the methods of the general button. Okay? Inheritance is when an object is created based on another object. So a triangular button is created based on a general button. So therefore it inherits all of its variables and functions. For example, an extension of the earlier square area calculation program would have a main object called a polygon. So again, it's backwards. The polygon is the general object, and the square inherits properties. Anyway, in geometry, a polygon is basically a closed shape, i.e. a square, a triangle, a circle, a cube, etc. All polygons, I don't think a polygon is a cube, actually. Or I'm sorry, I don't think a cube is a polygon. All polygons can have their area calculated. Right? A cube is a three-dimensional object. Anyway, all polygons can have their area calculated. Just the method of achieving such results is different, right? So, of course, we can talk about the area of a square, of a triangle, and so on, but of course the calculations are different. So in our program, the polygon object would have length and width variables. Really? Length and width of a triangle? This is kind of not so great. But anyway, since a polygon is not actually a shape, but a class of shapes, the area function would not do anything. In other words, it's too general, a polygon, so you can't say what the area function would be. But you could still have like it's kind of weird, but you'd still have an area function, but it wouldn't do anything, because you couldn't say what the area is for a general polygon. When you want to create an object for a particular kind of polygon, for example a triangle, you would use inheritance to create the object with all the properties of its parent. That's what I said. The polygon object. You would then cite the actions of the area function, cite the actions the area function inherited would perform. This concept is called inheritance. It makes much more sense when dealing with large programs, where objects typically contain lots of lines of code, in which rewriting an object similar to another would be tedious and pointless, when inheritance can be used to get the same properties and methods of the parent object. So again, we have the general button and then a triangular button. Triangular button will inherit all of the properties of the general button. Okay, so with that introduction to objects, and I expect that we're going to cover objects in more detail later, but we haven't been able to get there yet. So now we're going to talk about variables as objects, which is kind of weird, but in Visual Basic, variables are objects. That means, of course, a variable is just like a certain type, like create this variable as a type data. I'm sorry, as a type date. But this also, oh, and by the way, I forgot to say, when we access an object's properties, we use the dot notation, right? So we might have the name of our button, or suppose we have a label. Suppose we had a label called label 1, which we don't have, so it's going to give me an error. But suppose we had and then we could say like its text property, right? We access the properties and also the methods of a particular object using the dot notation, right? We've done that many times. Well, it turns out that when in Visual Basic, when you even when you create a variable like this, expiration, you can also treat it as an object, meaning that you could use the dot notation, and you can get certain so-called properties of this variable, and also, usually more important, certain functions or methods for this variable. So that's what they do here. First of all, they set expiration, they give it an actual value. Remember, these hash marks, or these pound symbols, are used like quotation marks when you're setting a date. I think we went through that. So if you're setting a date as a constant, or I'm sorry, if you're setting a date as giving a value for this date variable, you couldn't use quotation marks here, because then it would think it was a string. So instead we use these instead of quotation marks. So we're setting expiration to this value. Okay, so that's just, he says, so far nothing out of the ordinary here. But then we do this, expiration dot, and this is clearly a method because it's got parentheses there. So now even though this was originally just a variable, now we're treating it as an object. Okay, and that's what they mean when they say variables as objects. So we're going to talk about this next, and I'll stop this video and continue.